Good afternoon all, and lovely to see so many familiar faces in the room. It's a rare privilege for me to have a client alongside us in the form of EnBW. And if you don't know me, my name is Raj. I'm CTO of Digitaire, and today we have Andreas Evert, Head of Analytics, will be announced soon, from EnBW. Andreas has been a key sponsor of ours as Digitaire has been working with EnBW over the last 5 years, creating a lot of the front and middle office transformation work. With me today, I also have Remo Crescenti from Crescenti Advisory, who has been a very strong partner of ours as well while we've been doing all this transformation and change. To start off with, Andreas will be talking to us about the why. Why a change? So the next 20-25 minutes or so, we'll be understanding a bit more about the future of the energy trading markets and understanding the transformation that EnBW has achieved. Andreas will talk a little bit about the why, I'll talk a little bit about the how, some of the principles, and then Remo will talk a little bit about the what, the initial state and the transformed state. But to start off with, here's Andreas with a view on the fundamentals.
Yeah, thanks. There are many reasons why you need to change, obviously. The world is constantly evolving and we need to adapt. But there comes a point where you just can't continue with adapting the systems and the landscape because you have done it maybe over years and years, and then eventually it becomes a legacy, a burden. And you really need to think of, okay, I need to change something fundamentally in order to cope with the demand and the requirements which are ahead of us. And this is the point where you then need to rethink, you need to think about capabilities. This happened to EnBW when I arrived there. So we haven't invested so much in the system landscape, and we were at a point where we decided we would like to change our business model, we would like to grow. But then this happened. COVID, global crisis. The climate change is nothing new. Of course, it's a long-term development and a long-term challenge. But if you see the weather events that we face, that 3 sigma events happen every second day. And then as a result of the global crisis and some other aspects, then the responses with regard to security of supply and also the requirements and then the sort of actions by governments on regulation, you realize, okay, that there's so much that changed at the same time that you can't just create a transformation plan and then you do the data-centric model first and then you then adapt more and more systems and you go with it. You need to think differently. And the next slide I would like to highlight is about just one dimension of this uncertainty, of the change in the fundamentals, despite the legacy of our landscape. If you just look at weather, weather defines production and demand, obvious. But it also constrains your own production. So if you look at local weather, the inland waterways define if you get coal to our power station. If the water level is too low, then there's no coal, and no coal burn. And then your model, which is maybe a clean dark spread, is no longer a clean dark spread. It becomes nonlinear, highly nonlinear. And if you look at water temperatures, this is then defining if you're allowed to produce or not, the river temperatures. And it impacts your own production, but it might also affect then the France production, which then impacts the market prices at the same time, because the French nukes don't run. And if you look at our own production, then with more and more assets in our portfolio, which are weather dependent, like wind, offshore, and so on, you realize that you're short flexibility. And in markets which are quite volatile, being short flexibility is something different than you have expected. And it doesn't even need to be your own production. If you look at direct marketing, you do not buy the power, you basically balance their uncertainty. which is the production, and then you're just sort of exposed to some secondary markets, some ancillary service market prices. And I do not now explain the demand dependency on weather, which is then we have gas, we have temperature index, gas sales, and so on. I think the aspect I would like to highlight is that eventually we add a dimension to what we do. It's if you have a cross-commodity price model, it's not like that you then also simulate them production. No, you need to put it within the model because there are correlations. If there's no wind, then also maybe then it defines the prices in Germany, and this defines then also then your production. So you can't just treat them differently. They are nonlinear and they are highly correlated, co-integrated whatsoever. And if you then see that you have various systems where you basically have maybe data already embedded, you might have an external system which helps you creating long-term prices. And this software comes with weather scenarios. Then you realize that you have in all of these applications models weather data, but slightly different. It's like open an app on your iPhone and you see two different weather forecasts. And if in one forecast the wind's already blowing and in another one not yet, then you see a negative price in one and a production in another scenario. So the consistency challenge and the dimension, which is when translating into functional requirements like performance, is increasing. And this is the reason why we looked at, okay, what do we need to do in order to get from where we are to where we need to go? This is the next slide. And we need to look at what is our goal. We would like to gain a competitive advantage. That's the starting point. Given that we can't do everything at the same time, we need to look at, okay, where do we start? And if you go for that one as a starting point, then eventually you think, okay, if you consider SaaS solutions, then it's not because of maybe cost awareness, then it's speed. The idea is to get something in as soon as possible, and maybe then in future you replace the SaaS solution by something different in case you require it. We need to develop the infrastructure, but this is as the basis while we already introduce other systems. And if you talk about AI, then it's largely about, given that we don't know the future, eventually we need to be able also to model cause and effect relationships without knowing them. And that's far easier if you apply an AI method than trying to understand the complex logic between something fundamentally changing in China and having an impact on something in Germany. And how do we approach this? This is then, I think, topic that Raj will explain.
Thanks, Andreas. And one of the themes you can see here is the strategy for data. And what EnBW did quite well is embedding principles into the organization. And this is a genericized form of the principles that the technology firm took. So technology and data principles at heart. Picking a few, modularity, that Remo will revisit a little bit later. Distinguishing different component types. Being event-oriented, so literally listening to triggers, so being more push versus pull. And having business-oriented APIs. In addition to that, favoring OpEx over CapEx. That means we can leverage SaaS, we can leverage cloud, as we'll see in a little bit, as well as looking at existing solutions that have a core purpose. But then that thing that Andreas said about competitive advantage, I'd like to talk about that a little bit now. And then finally, embedding security in from the get-go. It's everyone's responsibility. Before I show the next slide, by show of hands, who's familiar with Wardley mapping or Wardley maps? One person, and he happens to own the company. Great. So a Wardley map is a way of defining strategy. And normally, I'll explain briefly, you normally have two axes. On the y-axis, you have visibility or value when it comes to your end user or your client. And on the x-axis, it talks about the evolution of software. So from the extreme left to the extreme right. From the left, you can see Genesis. So that's where ideas come from. That's where ideation happens. Then you see custom-built type solutions. kind of the things that Digitair's been responsible for, the front middle office for the last 5 years, and as well as products. So if you go down 2 floors and some of the vendor companies you have there, you might find a multi-ETRM strategy, for example, as well as vendors for analytics and market data providers. I've obfuscated the names here because Andreas doesn't want to do free advertising, he said. And then finally, on the right-hand side, utilities. So you can see that we're leveraging AWS as a utility. You may have also noticed products such as Datadog or Kafka, and you may think they're more products than utilities. However, they're quite easily interchangeable from a technology point of view. We can switch messaging systems pretty easily. We can switch telemetry systems pretty easily. Hence, you find them on the utility side. So why does this matter? It's because of what Andreas was talking about earlier, about organizing for speed, organizing for competitive advantage. So how do we do that? Well, if you look at the colors, everything on the left-hand side optimizes for speed. Everything on the right-hand side optimizes for efficiency. That's where you reduce variation, you have standardization. On the left-hand side, you reduce your cost of change and learning. That's where you have complex problems. That's where you have mixed discipline teams. But what does that mean? Well, it means that on the right-hand side, you can be quite commoditized if you focus your technology software landscape there. But on the left-hand side is where you find your competitive advantage. Now, that also gives us a clue as to how to organize our technology and also how to organize our people. So, for example, technology gets pushed to the right. So any of the vendor solutions that you've seen, but complex adaptive systems that need to be built, your talent is pushed left, whether it's internal talent or external talent. That's where you focus your efforts around your people, on the genesis and the custom-built part of the technology stack. As to the actual what's, the initial state and the final state of what was produced and the transformation that was achieved, I'm going to hand over to Remo.
Well, I'm talking about the what. What has EnBW done to transform towards having data consistency, coherency, as Andreas said the target would be, as well as modularity and performance concerning the infrastructure that's applied there, and also making some of the principles Raj just mentioned more concrete, fill them with examples. Starting with consistency in data. Andreas kind of touched on it. What is it you want? You want kind of to see consistency between weather data generation, production, consumption, and prices. So many of you would be familiar with a situation where you have consistency in prices only, where perhaps across markets, across commodities. So that's the standard, the usual thing. However, across these other information entities, that's where it's becoming difficult. So EnBW started in a situation where models were quite monolithic. Information was kind of used monolithic. What I mean with that, it was embedded in certain application silos, was quite use case specific. So there was not necessary consistency between the different applications and use cases in terms of interpretation of the information or the data itself. In addition, what has happened is that the quants were not just quant models, but quant developers. So basically, developing application, and in worst case, not just application, but also the underlying infrastructure and supporting that instead of focusing on their core skills, which is modeling. So the first thing EnBW did. Can you see the flickering there as well? So here it flickers. I hope it's okay for you. The first thing EnBW did was extract the models from those silo applications, put them on a common infrastructure, connected them to each other, as well as made them easily to integrate in any application. And that worked quite well. So that was not a long roadmap per se, but also the realization came very quickly that perhaps that's not sufficient. Applications need to be in some kind of context. So the data was still kind of siloed and inconsistent. For example, nothing was preventing anybody to use high prices with high renewable generation, which is not a typical market situation. So you had to bring the intelligence in somehow differently. However, with the move from the silos to new applications, the quant modelers could be freed from their quant dev work, and as such focus on their core skill, and with their core skill, if you remember the Wardley map and Raj's input, move them to the left and do the more complex things with the modeling, while the applications were supported by different people, kind of a separation of duty here. However, the target is not yet achieved. A target of data consistency. It's partly also because of these silos in terms of data, and perhaps also that the models are not yet completely connected in a way that they provide these consistent silos. But this data consistency is something to target for. This data, kind of creating this data pool, of course, is the eventual target. Moving from data to infrastructure, and with infrastructure to modularity and performance, where did EnBW start a few years ago? Infrastructure had been built over many years, and as such, sometimes had the character of black boxes, be it because the original creator or devs, they had left the house, but also because of the strong can-do attitude at EnBW, which resulted in workarounds, and those workarounds often also in combining, for example, parameterization with models or business logic with models, or bringing parameterization also into the code bases. So there was kind of this entanglement. And as part of that, the context of a certain silo application was somehow lost. So the use case was clear, but how it connected to others and the end-to-end process were not always clear anymore. Here, the first step was to build specific capabilities. So move one things out of legacy, build it newly, and separate all those different entities. So the modularity, business logic from infrastructure, from application, from model, from parameterization. These were separated. And even within the applications, there were separate services that were connected to each other and communicated with each other to make it very modular. So this was the first step, but it was clear very quickly that this is not sufficient. The use cases for an individual silo application, it's now modern and modular, were quite restricted. So unless we were going for a big bang, which was not a good idea or not considered, you need to somehow integrate. And with integration comes a certain understanding of the black boxes and certainly the end-to-end processes. And therefore, we didn't just build for a target situation, but we also built into integrating this into the legacy. And that comes at the cost. The cost is simple, and we can acknowledge it or not. It's the cost for transition solutions. It's the cost to remedy regression in those black boxes. That cost has to be accepted and is accepted. And that's something perhaps important to acknowledge, and perhaps a key message here. However, this is not just a regret. I wouldn't consider it a regret spend. This is also a learning curve for skilling up the people, moving them from right to left into the complex areas, in the ideation area, and building everything in a modular way. Change in the future will be simpler. At the same time, getting this understanding of these black boxes and the context and the end-to-end will help being faster in the future, and perhaps also having an end-to-end support model in the IT and in terms of monitoring. All that are targets, and we're getting closer there. A target which we will achieve, but perhaps not quite, and that's perhaps our take-home message now.
Yeah, as already mentioned, so when we created the title for this presentation, then the first question, or even today, had been raised, okay, if we don't know the future energy markets, how can you master it? And the question's obviously answered by, okay, you need to add functionality. You need to improve the system landscape to adapt more rapidly, in a more structured way to the challenges we don't know yet. That's obviously it's about data. And this is not just about databases. I think when we talk about a data-centric approach, then I think we often forget the complexity of a data model. So if you assume you have a multi-ETM landscape, and you export everything to one layer, an integration layer, then you have downstream systems like risk engines or whatever. Then you need to find a data model that covers the complexity of complex deals in one generic, whatever type of structure. So it's not like, okay, you just need to create a layer and that's done, but it's the art is often finding the right model, and then the data strategy and the data functionality is not just linked to cloud or whatever. It's really about also the sort of the logic you have implemented. At the same time, you need to recognize that it might not be just easy to build just one layer where you import data from outside. So often you have accept some diversity. You go for external solutions, but then you realize not everything is then mastered bestly there in an optimal manner. So you go then also for some direct APIs in case you need a particular speed or you have high volumes. So it's really about finding the data owner in the business that can explain the content and finding the right approach for each data point and yet integrating it. This then relates then to the second aspect which is mentioned here, the capability, as already pointed out by Remo. Okay, we need to move the business closer to the left side, so the complexity to competitive advantage. And this is done by bringing in the right stuff, but also applying latest technology. Just make sure that we are ahead of the curve. Organizational aspects, don't want to mention so much here, but obviously such a transformation can only work if you have a heavy involvement from business. I think it comes without saying, but the challenge is not to get them motivated. The challenge is the capability. Often you have a highly motivated business team that is ready for change, but let 20 of them work collaboratively in a project. It's not easily just delivered because of business involvement. If you just asked for requirements, you get such a huge list. You need somebody to structure it. That's the organizational aspect of it. It's not just the right organization, but really also to organize the transformation, where you have people who take leadership also to reduce requirements and define the path to something which is then achievable in a decent amount of time. And that's basically where we are. We are in the midst of a transformation, despite already being on the path for quite some time. I think we see various positive results already, but we constantly face the challenge of complexity. And that's only mastered, in our view, via different approaches and a smart sort of a setup when it comes to, okay, where do we buy something, which is a commodity, and where do we basically invest time, capability, training, and basically invest in that point where we think that's the result that is exactly then bringing us one step further.
Thank you, Andreas. Gavin, I believe we may have a few minutes for a Q&A at the end. Otherwise, we're happy to be connected via email or LinkedIn.
Certainly, there we go. We certainly do have a few moments. So I don't know if any questions are coming in, but by all means, raise your hand if you've got one and ask away. I see one here.
Hi, Ian Murray, Digitaire. I love the story. What's next? So for you, Andreas, clearly you've talked about a journey that kind of never ends, and this is a 3-year program of work. What's the next hop? What's the next iteration from here?
Difficult to answer. Obviously, we are. It's clearly about the integration. So if you create a patchwork landscape, which by definition is something that's the only possible sort of outcome in a short period of time, because we can't wait for something to be developed and then being deployed, because the opportunities and the risks are out there. So we patch. And the next step is obviously then improving the integration layer. And once this is done, then you can think of, okay, where of this sort of, where do you maybe repatch? Where do you sort of replace something external with an internal solution because you would like to get a higher consistency or another competitive advantage? So, but it's largely about creating the glue that allows you to master the complexity.
So I recognize the need. Systems evolve over time, they get changed, people add on bits, there's a problem, so a workaround is found, that gets added on. So I got completely the need for change and for doing this. But what I was hearing is it's not a 3-year thing, is it? It's a forever thing, actually. Or isn't it?
Of course, it goes without saying that you can phrase we will never reach our target and so on. There's clearly a consolidated effort to tear down the existing landscape and build basic capabilities. But
okay.
And you do not then sort of stop here and then you are finished. But nor do you just constantly sort of
so it's a big push.
Develop and destroy. There's a big push as such.
It's a big push for 3 years, and then it becomes business as usual to modify and improve.
Exactly.
And to keep up. I shouldn't have said keep up. I should have said keep ahead, because you were talking about competitive advantage there. Yes. Okay. So, any questions around the room? Yes, we do. Let me.
Yeah, no. Just a quick question regarding the organization part of it that you mentioned. You mentioned something about a business team, and you have a business team. And if I take the drawing that you had saying you're moving people to the left, right, and technology to the right. So how specific are you organized regarding IT people, quants, and business people? Are they working close together? Are you still divided into IT and business? Or how does it look for you?
So I think one of those slides we mentioned that where we started, we had quants operating systems. And that's obviously then not optimal for many reasons, even sure if it's compliant. So we would like quants to focus just on modeling, and then obviously then have others focusing on the infrastructure, and then depending on if it's embedded DevOps or not, then even then the guys who develop the infrastructure maybe even operate it, but it's all IT. So when we develop an application or a component in that landscape, it's of course a close cooperation between IT and the quant team or whatever the business team being involved. But it's also quite often that it's not just IT. IT is an internal department which often do not even have hired coders. No? I've seen companies which basically outsource so many aspects. So it's all in a combination of different groups contributing to one target. And what's relevant in context of our work here is that that we need to avoid, that we need to program management. So because if one system depends on the other one and then the other one on the other, so eventually we are in a situation that in particular to ETM solutions or data solutions, we need to prioritize between those. So we need also some sort of organization that it's above that coordinates between different priorities and so on. So its results quite difficult. But the business model for this is business even codes and develop something, infrastructure IT, operations also IT, and what you can outsource, then you also outsource of course.